Thanks for joining. Thanks for joining. Dang, looks like my connection's kind of weird. Poor connection. All right, looks like it's a little better now. What's up, everybody? Thanks for joining. So I'm live on TikTok, Instagram, Facebook, Twitter, YouTube, and Twitch. I'm everywhere. So I got this thing set up right here. I have this phone. I have 2 phones set up, and then I'm streaming to like 4 other platforms through the computer. So welcome to the stream, everybody. It seems like on Instagram it keeps on pausing the connection. I don't know why. Maybe because I'm streaming too many things at the same time. But anyway, thanks everybody for joining. Why is this connection weird? I don't know. But anyway, I'm going to go ahead and try to get started. So yeah, tonight, what am I doing tonight? I'm back live. I'm doing some more coding. Tonight is a coding challenge. I am doing the problem called pour water on Leetcode.com. And so pour water is a medium problem. So this is the first medium problem I'm doing with a little more difficulty. And pour water goes as such. So you are giving an elevation map represents, this is like, is that right? You are given an elevation map represents as an integer array. I think this should be represented. You are given an elevation map represented as an integer array heights, where heights I represents the height of the terrain at index I. The width at each index is 1. You are also given 2 integers, volume and K. Volume units of water will fall at index K. Water first drops at index K and rests on the top of the highest terrain or water at that index. Then it flows according to the following rules. If a droplet would eventually fall by moving left, then move left. Otherwise, the droplet would eventually fall by moving right, then move right. Otherwise, rise at its current position. Here, eventually fall means the droplet will eventually be at a lower level if it moves in that direction. Also, level means the height of the terrain plus any water in that column. So cool. So we can assume that there is an infinitely high terrain on both sides of the bounds of the array. Also, there could not be partial water being spread out evenly on more than one grid block. And each unit of water has to be exactly 1 block. So yeah, this is a long problem description. And I don't know, like, let me know, comment if you can see me on Instagram. It keeps saying the connection is reconnecting, but so I'm not sure what's going on with that. But it looks like people can see me. I'm not sure. I might reconnect this for Instagram. Yeah. Now let me stop Instagram and start it again. Give me 1 second, folks. Sorry about that. Instagram is acting a fool. Not sure why. All right. So we're going back live on Instagram. And it keeps doing the same thing. Pause due to poor connection. So I don't know why it keeps doing that. Anyway, I think I'm just going to keep going. I'm going to try to change the network connection. And then after that, I'm just going to keep going. Change to a different connection. All right. So now it seems like Instagram is working now. So I changed the connection. So cool. Thanks everybody for joining. TikTok, everywhere. YouTube, Twitch, everywhere. So I'm going to go ahead and get started. Problem is poor water. I just read through the problem description for anybody that missed it. But I'm not going to read through the problem description again. What I'm going to do now is go through the examples, and we can kind of figure it out from the examples themselves. So using the visual here, this problem is basically like water is falling somewhere in this grid, and then it needs to like sit in one of these blocks. So if you see here, this example, the blue part is water, and then these like red parts are like Mario bricks or whatever. And so the water at index K, the water is going to fall at that index. And that is one of the parameters of our problem. So like if K is 3, then the water is always going to fall at 3. So think about a leaky faucet that's just like sitting over index 3 here, this column, and water just keeps falling at a volume of 4. So at the volume, y'all can't see that, but the volume of 4 right here, the water is going to keep falling. So what the problem basically says is when the water falls at 3, it should go left. And if there's a lower spot than the place that it fell left, it should fall into that spot. And then as more water falls on 3, the water will try to go left and fall in a dip. So here, if water falls again, it'll slide to the left and it'll find the next dip and fall in. So here it's fell in 2 times. Here, there's the 2 drips that have occurred. And then on this third drip, it'll fall. And the problem states at the top here, if it cannot fall by, if it can fall by moving left, then it'll try to fall and move left. Otherwise, it'll fall by trying to move right. So if you see in this scenario, when the water drop falls, it can't fall going left. So it's going to try to go right. And so by going right, it falls into here. And so the last water drop at volume 4, it stops here because it can't fall by going right, or it can't fall by going left. And that's in the problem description in this third point here. Otherwise, rise at its current position. So the water level rises at the spot that the water dropped. So as you can see, it gives you like a visual of each step. And so volume is how many water drops are going to fall. K is which index here the water is going to fall in every time. And then the heights are 0, 1, 2 through 6. Those are the heights of your bricks, like the original height of your thing. And so what they want you to return is the new height of the whole thing, including the water. So the bricks plus the water, the problem wants you to return the new height based on the position the water falls in and based on how many water drops or water units actually fall. So I hope that makes sense. This is a medium problem, so it's definitely tougher. And hopefully I can figure this out. If I can't, I'm going to find the answer. And y'all are going to see me go look for the answer, which is cool. Somebody said, I love your content, bro. Man, appreciate that, man. That feedback goes a long way for me to keep doing stuff like this. So anyway, there's constraints here. And if you're like in an interview setting, then these might be things you have to ask the interviewer for. But Leetcode gives you these by default. So here, we know that height's length is greater than 1. So we'll always have one column. Like we'll always have at least one column, and then we'll have these walls on each side. And then height I is either 0 to 99. So the height could be 0. There could be no bricks in one of the columns, or it could be up to 99. Volume is from 0. We could have 0 drops, or we could have 2,000 drops of waterfall. And then K has to be greater than or equal to 0 and less than height length. So it's just basically saying the water can only drop in one of these indexes 0 through 6. And it doesn't have to be 6. It can be whatever the height of this is. So it's one thing not to get tripped up on these problems is the examples they give you are just examples. So you have to look at the constraints to know what your possible examples can be and try to find edge cases from there. So for the sake of time, I'm going to go through my thought process. So if you watched my videos before, my thought process behind doing these problems, and I want to admit I've done this one before a few weeks ago, but that doesn't mean anything because you can forget and mess up still. But when I think about these problems, when I first see them, I try to think about how I would solve it in my mind and on paper. Like if I had to have a whiteboard or something like that to solve it, I think about how to solve it that way. And then I take whatever my solution is or potential solution is, and then apply it to code as far as what data structures do I need and what algorithms that I can use to solve the problem that I just thought about in my head and on paper, or vice versa, or not vice versa, but either or. So what I'm thinking about for this one, when I look at this problem and I look at each step here, I know that first, when a water drop falls, I need to start checking the heights to the left first to see if there's a height lower than the current height of where my water fell. So if my water falls on index 3, I need to go left, subtract one index from the one I'm currently looking at, and then basically drop, like once I find an index that has a height that's lower than the current one I started with, then I know I can drop the water there. I come back out of my check and then I add the water to the height of this object. But if I get in this case where there's no possible drop, where it always equals like the same height, then if I get all the way to the end here, then I know I need to stop this and I need to go check right to see if I have a drop on right. And if I have a drop on right, drop it in the right side. And then, of course, the last case is if I don't have anywhere to drop on either side, then I just drop the water where it just dropped at in index 3. And another case is, one thing when I originally did this problem is so just say I run into a wall. Like, I think there's an example down here where you can run in. No, there's not. But like, let's say not a wall, but let's say the water drops here. Like the water drops down here or something, or maybe it drops over here. I'm trying to think of what's the best example. But basically, wherever the water drops, if I run into something that's higher than where the water drops, it can't jump over a wall to get to the other side. So I have to stop wherever the water, if I find a place where the water is, where there's a wall and I can't get past the wall, because the water can't possibly drop if it can't get past a wall. So that's an important edge case to think about as well. So with that being said, I'm going to try to jump over to the code and see if I can do this in like 10 minutes, 20 minutes, I hope. We'll see how it goes. I kind of have my image in the way, but I'm going to try to keep the screen up here so y'all can see. Looks like everybody can see everything. So cool. So I'm going to get started. So as I talked about in my solution, or as I was thinking about the solution, and I didn't do it on paper, but like it'd be really, if you had the time, you probably wouldn't in an interview setting, but if you had the time, like doing this on paper, to try to like think through it or like write down notes or scratch paper kind of helps think through this stuff. But when I was looking through my solution, or when I was thinking about my solution, what did I say? I need to go left first and check that there's any lower index than the current one that I'm on as far as height. And then I need to go left. And then if I can't go left or right, then I just drop the water where it is. And when drop the water, what that means is increase the height at that index. So as the problem stated, index I in this array, it's an array of heights. So like this array has the height of 2 right here, 1 right here, 1. So if you see 2, 1, 1, 2, this is 2, this is 1, this is 2, and 2. So that's why this array looks like this, because it's the height. So when a water drops in, then I add to the height to take account of the water. So by the time I get to the end of my problem, and where's the end of the problem at? Here. I have added all the water into the array of heights. So that's kind of how you have to solve the problem, or definitely how you have to solve the problem. And yeah, so let's go ahead and try to jump into it and figure it out. Yeah, somebody said a PSD is like a graph matrix problem. Oh, hey. Yeah, so yeah, this is this is definitely one of the tougher ones for me when I first had to try to do this. But yeah, so this is how I solved it. There's probably multiple ways to solve it, but this is what like kind of my intuition led me to. And so what do I need to do? So the first thing I need to do is look at K. K is where my water is going to fall in heights. That's the index of where my water is going to fall. So what I need to do is basically get a current height of like where I'm at. So like heights, and this is guaranteed for my constraints to be there. So I need a current, this is the current height basically of like what's the height at which my water is going to originally drop. So when in this problem, the water is going to drop at index 3, and the height at index 3 is 2 bricks. So it's 2. So this actually would spit out 2 to start with. And then from there, I have volume is how many water drops that I need to drop. So from there, I actually need to loop through water. And how I'm going to do it is I'm going to say like drop or something like that. This doesn't matter. Like I really just need to loop through this a certain number of times. I don't need to use these values. So you could use like a array with an index or a loop with an index, or you can use like a for loop like this. And so when I get in here, what do I need to do? At every drop, I need to look left, look right, and then look at the same index that I currently have. Like if I can't go left or right, I need to drop the water in the place that it is. So how I thought about this problem is that I need to know where to drop the water at, what index to drop the water at, no matter what I do. And so my first intuition is to make a function called like find left index, and then return that as this is where I need to drop the water at. And then I can make another function called find right index if I end up having to go right. And then this is where I need to drop the water at. So I can do this where I can say left index equals find left index. And so what goes into left index? So what goes into left index, and let me make sure I'm not forgetting here, but I need to pass in my heights. So I need to know what my heights looks like. And I need to pass in the I might not need to put this here because I might better do this inside of the function, but I need to pass in K so I know where I'm at. And then when I get in here, I actually could just get the current height here, I think, instead of here. Or I can just pass it in, but I don't know. I can just get it from here. So basically I'm passing in heights and K. So now I know, now I need to find, based on heights, when I look left, where is the first drop at? So basically I need to loop through the heights and look left. So how do you go left in an array? You basically need to go backwards in an array. So where's my starting point? My starting point is K. I'm going to start with K, and shoot, it might be K minus 1. I think it might, yeah, I think I need to start at the next one and not this one, but I'm going to try this first. And then where I is greater than or equal to 0, and then I minus minus. So I'm basically going in the array to the left from K, because that's where I dropped the water at is K. So I don't need to look any different spot than that. And so now when I look at this current height, so current height is K, and this is the current height, and then this is like, I don't know, this is like the new height that I just found. So I need to use I to get that out. And then I look at new height, Okay, so now I'm at my next spot. So if the new height, so the next, so I do think this would be k minus 1. But I don't want to do that because I don't want to have to do a bunch of logic if k is like next to 0 or something like that. So I'm going to just do the processing on k. But so if new height is, let's see, if new height, if I'm going to the left, so now I'm doing some critical thinking here. So if I'm going to the left index, let's say I started on 3 and I go here. If new height is greater than the current height that I'm on, then I need to just stop and return my current index. So I basically need like found index or something like that. And so I want to say found index is current height. And then I want to return found index here. So basically, if the new height is greater than the current height, let's see. Yeah, if new height is greater than the current height, then I want to break out of this loop. And then when I break out of this loop, I'm going to return found index. And so found index equals basically whatever I found, or basically it just breaks out. And it, well, no, I think in this case I need to, yeah, I need to break and use whatever I found. Okay, so I think, yeah, in this case I think this is right. So the other case is if current height, or sorry, new height is less than the current height, I have a drop. So here, if I go here and the current height is lower than the height that I started with, or sorry, the new height is lower than the current height that I started with, then I have a drop. And so found index should be equal to I at that point. And I think maybe I should break at that point too, now that I'm thinking about it. And just go with found index. If I run into a wall before I find the index, then I should break and return current height. So matter of fact, I'll just go ahead and just return the current height here in this case. And then here, I'll just return, because yeah, what if I don't, yeah, if I don't find anything, so yeah, so I can't do that. Because there's a case if I don't find, like in this case here, where it's just a long walk, like a long, I won't find anything higher or less than this whole way to 0. And in that case, I need to return the index that I'm currently on. So that's why I do keep the index that I'm on within this logic. So I think this is right. So yeah, if I run into something that's higher than what my current height, which is basically the height that I start with, then I break out and I just return found index, which in that case would just be the current height. And then if I find a new height that's less than the current height, then I know I found a place to drop down. And then I change the index to that index, so I return that back out. And so here, if the left index is less than k, which is basically where I am right now, then I need to basically take the height for that index and put the water there. So this is how I put the water in. So I found the index where the drop is. And so if it's less than k, then I need to put the height there. because that means I found a drop that was on the left side. And so I need to add height there from this function that I made. Else, what the problem say, I need to go right if I can't find a left index. So here, if I didn't find a left index, then I go right. And so here I need to call the same function, but on the right side. Or not the same function, but I need to call the find right index function. And this problem is definitely more complicated. It's hard to explain this problem. So I hope you guys are understanding. Like, please let me know if you have questions or anything like that. But yeah, this is a tough one, man. This is a tough one to think through. I guess it's why it's a medium. So anyway, right index, I'm just going to copy what I have here and change the logic based on going right. So how do you go right in a loop? So my current height should be the same as it was. Oh, I need to pass my variables in. And you guys might not even be able to see this down here. So I need to pull this up so I can make sure y'all see what I'm seeing. So yeah, I need to put my variables in here. And then, so yeah, current height is the same, found index, the same logic. But here, how do I go right instead of left? So I should still start with K, but I should be less than heights dot length, because I'm going to the right now. And so the end of my thing is here. And then instead of minusing, I need to add, because I'm going right in the array instead of left in the array. I'm going forward in the array instead of backwards. So then I get a new height, and I think this logic still applies. If new height is greater than, then I just break out, because I've run into like a wall. Water can't jump over something higher than itself. If the new height is lower, then I found a dip. And I need to set my found index to that dip and return it. And so here I find the dip and I just break out and return it. And so I think that's right. So then back in my original logic, I have my right index and I do the same sort of logic to say, but it's a little bit different here. So if right index, basically if K, wait, no, hold on, let me think. If right index is greater than K this time, because I'm going to the right, that means I found a dip and I need to add the water at that spot where the dip is. So right index plus. But if I don't find a dip, that means I didn't find a dip in the left, so I went else. And then I didn't find a dip in the right, I went else. Then what is the problem statement say I have to do? In that case, I need to add the water. This is this third case here where I need to add the water here. It couldn't go left, it couldn't go right, so the water just sits at where it landed. And so come back here, and so then where it landed? K is where it landed. So it landed at K, and so I need to add to K. And then once I get out of this for loop, I've dropped all the water. So I do this the number of times of volume, which is the number of waters that we have. And I keep adding water to heights. And then once I get out of here, now I have a heights that has all this water added. And I simply need to return heights as it's been mutated to have the water that I dropped inside of it. So, yeah, somebody said, good stuff, Cooler Shadow. Thanks for joining, man. Thanks for the feedback. So yeah, I think I'm done. Now, will this work? I do not know, but we'll see. But what I like to do is, and what a lot of times you have to do in interviews, and what you kind of should do normally is like trace through the code itself before you run it to make sure that it makes sense. So I'm going to trace through it with a problem, but first I'm going to trace through the code, just read through it, make sure I don't have any like bugs or anything as far as the code as it's written. So I pass it in heights, volume, K. That was what was given to me in the problem statement. So I'm going to do a for loop for every volume, and I don't care about these values, but I'm just doing a for loop to do this loop this many number of times. Have this find left index function. In find left index, I take the heights and K, and I get the current height that I'm on. and then I set that to found index, which is my return variable. I loop through starting at K, and I say as long, and I go backwards until I get to 0, and then new heights equals, uh-oh, somebody's calling me, but whatever. So I say new heights equals whatever current height that I'm on in this loop. And if new height is greater than current height, then break. If it's less than, because I've run into a wall, if it's less than, then I need to, uh-oh, my screen moved a little bit. If it's less than, then I need to set the found index to this and break out as well, because I've found a dip. I found my first dip. Move this back this way. Yeah. Right. So return found index. And then to find the right index, I need to, well, no, I'm sorry, I'm going wrong. So yeah, I find the index, return it. Then I go back to left index here. And then if the F index is less than K, so I didn't like just set it directly to K. And now I'm thinking, you know what? This is not right. This should be, so this is why you find bugs. So here, found index actually shouldn't be current height. It should be K. I should start it at K. And not, because a current height is not equal to an index. K is equal to an index. So yeah, so I like K is probably better to be like, name this like drop index. You know what? Yeah, that's what I'm going to do. This will make it more clear. This is the drop index. This is where the water dropped at. Drop index. Drop index. I hope this makes more sense to everybody. It makes more sense to me. They call it K, but really K is the drop index. Where the water dropped at. So I think, do I have any more references to K in here anywhere? No. So yeah, I almost messed up there. So that's why you read through this stuff. Yeah, so if left index is less than K, then I found a height and I need to add it. Else, I look in the right index with a similar function, but just going backwards or going the other direction. So yeah, if it's less than height length, I started my drop index. I set my drop index to here. I look at my current height. I compare my new height at whatever index I'm at to it and break if I see something higher, and I drop out if I see something lower. I break there. And so yeah, this code looks good so far. And yeah, I find a higher index on the right side of my K, my drop index, then I add to the height at that index. If not, if I get through all of this and I haven't found anything, then I just add it at the drop index to the height. So my water drops in at the point of its drop. It just stays where it's at because it can't go left and it can't go right. So, man, with all that being said, so what I usually do here is run through the code manually. So I'm setting up some values, and what you do is, what I like to do is like like to take every single one of my and I'm gonna actually put drop in here too, like what water drop number are we on, and then left index, right index. So I take all my variables and put them in like a comment, and then update them as I walk through the code manually before I run it. So let's find one of the examples to use. We're going to use, let me see. I wonder if this is a good example to use. Yeah, I think this is a good example to use to make sure it works properly. I want to use the first example, but it seems like it's a long problem. Because I only have 4 water drops, so it's not that bad. So I'm going to use this example. So it's this, 4, and K. So let me go back over to my code, put in my examples. It's 4 water drops, and K is 3. My bad, not K, but 3. So now we're coming in with, this is heights, volume 4, K is 3. So now we're going to loop through our drops. So we're on drop 1. I'm not going to use a zero-based index because I don't care about what this value is anyway. I'm just going to go 1, 2, 3, 4 to match with the volume that we came in with. So left index, just find the left index by passing heights and k in. So heights is this value up here and k is 3. So what is the current height? And really I need to put in variables here for these things. So current height, found index, and what else variables do I have in here? I have new height. So this is kind of a long problem to talk through, but I'm going to try to do it fast. So heights at drop index is 2. So my current height is 2. The drop index is 3. And then I have my new height. And yeah, so I set found index to drop index. And then when I get into drop index, I'm going to find my new height, which right now drop index is 2. So if I look at my array where it's 2, 0, 1, 2, 3. Wait, no, I'm sorry. Drop index is 3. So I'm going to start at 3, and I'm going to find a height of what 3 is 2. So the new height is 2. So with the new height being 2, 2 equals 2. So I don't get into any of these conditions. So I basically skip both these conditions because it's not, new height isn't greater than or less than, it's equal to. So then I go back in my loop and go down 1. And it's not greater than 0. So now my new index, since it started at, which I probably need to keep something for I too. So I started at 3, and now it goes down to 2. And so now my new height is, my new height at 2 is 1. So then new height is greater than this or less than. It's less than. So now I'm going to set my found index to this index here, which is 2. And I'm going to break. And I'm going to return found index as 2. So then I come back here. Left index is equal to 2 because that was my found index. Is 2 less than k? Well, so this is 2. It's 2 less than k. Left index less than k. That I'm here. Yes. So I'm going to add to the height at index 2. I'm going to add 1 to it. So 0, 1, 2. So as you can see, my water dropped here. And then it moved over down into this spot and added 1 water drop to this spot here. So this is basically how you would track through this problem. I don't think I'm going to track through this whole problem because it takes me so long just to get through one thing. But basically, I'm not going to go that slow, but I'm going to kind of like speed through the rest of this. So when the next water drops, I'm going to go back in here and I'm going to try to go left. And then I'm going to go through that same logic again. And based off the logic, I'm going to find a dip at index 1 because I'm going to keep finding the heights are going to be the same. And then I'm going to finally find a dip before I find something that's like a mountain or whatever. And then the next one over is 1. So the next water drop is going to drop here. And then when I come back in here again, this is where the code changes on me a little bit. I'm going to come and try to find my left index for, so let's say I went to drop 2 and then now I'm at drop 3 and then left index is blank again. And so then I'm going to go into left index, find left index, and I'm going to try to find the left one, but I'm going to see that all of these are equal to 2. All these heights are the same as I go backwards. So I'm not going to hit any of these. I'm going to return the same index that I came in with. And so then it's going to say, is left index lower than? No, it's because it's equal to. So I'm going to go into my if case and go right. And when I go right, the logic here is going to do the same logic, but going right in the array. So I really don't have to go through this logic again, but I know from looking at this, the next dip is over here, and I'm going to add 2. And so then I'm going to go to my last drop, and I'm going to not be able to go left like I just tried to, and I'm not going to be able to go right because there's no drop. All these are equal, and there's no hill either. And so then I'm going to get into my last final case of adding to K, and K is here. And so it's going to be 3. And so it's going to be 2, 2, 2, 3, 2, 2, 2. That's the answer. And heights is going to get returned down here as the answer. And what was the answer for our problem? It was 2, 2, 2, 3, 2, 2, 2. So that makes sense. That works in my head. But working in code is a whole different story. So now it's kind of the moment of truth to try out the solution in using Leetcode's runner. And so, yeah, I'm going to try to run it and see what I get. So I got an error. Volume is not iterable. Oh, so I messed up there because I thought that I used this as an array, and that's not right. So, so the mistake, anybody may be able to see and call out the mistake I made. Yeah, somebody said explain the for loop. Yeah, because the for loop doesn't work properly, so it's not right. Because I was treating this as an array, like looping through an array, but really this is a number. So I can't loop through it like this. So this is where I kind of messed up at. So what I need to do is while I is less than volume, do like that. And so now I'm going to loop this 4 times because volume equals, whatever volume equals to, that's how many times I loop. So thanks for asking about can you explain the for loop, and I end up finding that as a bug in my program. So yeah, that's a bug. And luckily that was an easy bug to find. But once I run it after fixing that bug, I completed all 3 test cases that were over here on the right. So the first test case that I ran manually worked, that 2, 2, 2, 3, 2, 2, 2 one, as well as these other test cases here that Leetcode gives. So this is looking good so far. So the only thing left to do, you wouldn't do this in an interview, but if you got an interview case, if you were able to run it and you beat these test code cases, you'd probably be okay. But in Leetcode, it actually lets you submit it against all the other Leetcode submissions and lets you see like how well you did against everybody else as far as time complexity and space complexity. And one thing I didn't do, which you should do, is talk about the complexity of the solution. Like what's the space complexity and what's the time complexity. So the space complexity, I'm not storing anything besides the input is a object itself, but my algorithm doesn't use a data structure that is based on the size of my input. So all these are like linear operations. So my space complexity is linear or big O of 1. And for my time complexity, I'm basically, so for every single, doing an operation for the volume, and then for every drop, I need to go either left or right to find and add the heights. So at worst case, I'm going to go completely left, or I'm going to go completely right until I find something. And so to me, I think that makes the problem like n times m, where volume is, or maybe you could say like big O of like x times y, where volume equals x and y is the length of heights. And so this one is definitely a more complex time complexity. And I'm going to look that up to make sure I didn't tell y'all wrong on the complexity there. I'm going to look up the answer later after I run this. So anyway, without further ado, I'm going to run it against Leetcode's thing. Oh, it looks like I have some kind of issue with this problem here. So it looks like for some reason, this with volume 10 and k equals 2, the solution didn't come out right. So now I got to figure out like what went wrong with at that level. It's probably some weird logic I have in here. And so your index is 2 where it's dropping the water in, and then it's going down this way. Oh, it's like actually like, let's see. Yeah, something's wrong with my logic in here. And I don't know what it is. Let's see. And new height is greater. I think something's wrong with my left and right logic here. I might not need a break here. Let me try that out and see what happens. Cause I might need to actually slide the water as far as it needs to go to the left, but I'm not sure. Oh, still wrong answer. Even worse answer on that one. So left, right, height is greater than, height is left in. Yeah, I don't know what's wrong with this. Like why I beat the first 3 test cases, but then when I run it against all the test cases on Leetcode, it fails. So there's some sort of issue in here that I need to figure out. Height, drop index. And if height is less than the index, increase it. All right, index, increase it. Otherwise, increase this. So, okay. So I don't know what the problem is. And for the sake of time, I'm just going to look up my previous answer, because I'm not going to sit here and just have y'all on here watching me struggle. But yeah, I'm glad I did this problem again, because I did this problem before and got it right the first time. So I don't know exactly what I did wrong as far as the answer. So yeah, as you can see on September 19th, I did the problem correctly. And I thought I did it the same exact way, but I guess not. So yeah, I have my current height here. And then I passed in current height every time, which I don't need to do that. Left index is less than, right index is greater than. So this logic all looks the exact same as what I have. So where did I mess up at? It's gotta be down. Ooh, yeah, it's down here. If new height is less than current height equals new height. Oh, I know where I messed up at. Oh, yeah. Man. Okay. So I really messed that up. And so this is a good learning moment and like teaching moment for where I messed up. So where I messed up at is, let's say, so I'm only thinking about dropping down 1. What if there's a lower dip to drop down? So like, what if there's like another, I wish they had an example here. They don't. But let's say a water drop fell here and I need to drop down 1 and then there wasn't any water here and I need to drop down 2. So my logic only drops down 1 and then it breaks out. So that was the problem. Like I shouldn't break out here at 1. I should change my current height to a lower height. So basically, I need to not break here and make my current height equal to my new height. Because now I'm at a lower height and I need to check the rest of this against the lower height to make sure I don't have anything lower than my new height. So man, that was a good one to run into. I'm actually glad I ran into that one. And it didn't even show up in any of the examples, which was crazy. And then I didn't find it when I ran through the code like myself because it wasn't in the examples. So that's why like you have to kind of come up with your own examples. What I should have did is came up with an example where the water drops down twice. And so now let's run this again. See, yep. And that was it. Yep. Dang, my runtime beat 100% of people on Leetcode. I have never beat 100% of people on Leetcode with runtime or memory. I need to post this, man. I need to post my solution. My solution must be good. 100%. So that means I'm like, that means it's better than anybody. That must be wrong, man. I don't believe it. But yeah, so I accepted all the different use cases or test cases. So yeah, I got through that one. I had to cheat. I had to look at the answer. In an interview setting, you might get a tip that would help you. So that kind of like a tip. You know, you should ask for a tip, honestly, if you get stuck like that. Because even though if you get stuck like that, if you ask for a tip, in a real scenario, you would look that up. You know what I mean? Like if you're at a job, you're going to look it up anyway. But in an interview scenario, you could ask to say, they would maybe help you on their own, but you could ask to say, I don't know what's going on. Like, what do you think? Like work with them to try to get them to help you. And a lot of times, if I would have got that quick tip hint, I would have been able to fix that on my own. Just like when I just went and looked at I actually looked at the code, so that's probably worse. But if I would have had a tip, I probably would have figured that out a little bit easier. But yeah, this is the first medium I'm doing, so I have no shame in having to look figure out the answer, because I'm just trying to learn here, of course, and trying to get better as everybody is at these. So I appreciate y'all folks watching. I got people on Instagram. I got a couple folks on TikTok, people on YouTube, Twitch. So like, please follow, please like, share the video, whatever you want to do. Favorite the video after it gets posted. Somebody said I sound like yay. That's crazy. I don't think so, man. But okay. But anyway, yeah, like, subscribe, stuff like that on all the different platforms so I can do more stuff like this. And let me know what you think, like if you could do it a better way, or if you have any questions, anything like that. I appreciate you guys for joining. I appreciate the time. And I'm going to do more videos like this where I share coding challenges as I'm working through them, as well as like general coding projects that I'm working on. I just have y'all code with me, or be with me as I code through some of my projects. So yeah, stay tuned, man. I appreciate y'all, and I'll see y'all in the next video. I'm gonna jump offline here.